Okay, now we are going to look at another subtopic from chapter 1 additional maths from 4 functions, which is composite functions. So we look at the example questions. Given the functions fx equals to 5x and gx equals to x plus 3, find the composite function of fg. So composite function involves at least two functions. So here we combine the f function and the g functions. So what the requirements of the question actually is, they want us to look to find fgx equals to what. So we look at this composite function here. G is inside f. Okay, so meaning that we are going to replace x here with gx. So given the gx is here, meaning that we are going to replace the x here with gx and then replace it with x plus 3. So we come back to this. So it actually means f gx here, meaning 5gx. And then the gx we take from here, it becomes 5 times x plus 3, which is equals to 5x plus 15. That will be the answer. So fgx equals to 5x plus 15. And again, this is the basics of this composite function. We now try gf. Gf basically means gfx, meaning that we are looking for the function inside is f here. So it's gfx. Now we replace the fx with 5x. Becomes so it's g 5x. So we substitute the 5x into this function here, which means into this into this x. So you get 5x plus 3, which is 5x plus 3, the answer. Now we try the second one. Given fx equals to x squared, find f2x and f3x. So f2x actually here means fx, not the square. And here it means fff. Okay, so it's not a cube. I'll have to be very careful. So this one, from here we know that is fx. So the fx given here is x squared. So now you have an x squared here. So from here we know that the x squared actually we need to substitute into here. So meaning that the x here is substitute with x squared. So you have an x squared squared. Yeah, f squared squared here. You get x to the power of 4. Whereas for this is equals to fx, which is actually equals to f2x. So the f2x, we already have the answer from here, which is x to the power of 4. So we only have to do this once. So x to the power of 4, now we replace into here, and then substitute into here. Then we get x to the power of 4, this one, and then we to the power of 2, to the power of 2. So if this is brackets, it means 4 times 2, you get 8. And that will be the answer. Now we continue. Given fx equals to 5x and gx equals to 2x minus 4, find fg, the composite function of fg, 4 and gf negative 1. So the function here is a separate function, it's a f and a g. But here we have a composite function. So it's very obvious that we need to find fg, the function of fg, composite function, before we can find the value of fg4. So the first thing we do is we find the composite function of fg using the previous, like the previous method lah. Okay, so fgx is, g is inside, so g is inside here, inside the f. So we replace the gx with this, 2x minus 4, you get 2x minus 4. So now it means that the 2x minus 4 we substitute into here, which is substitute into here. So you get 5 2x minus 4. Get 10x minus 5 times 4 is 20. After we find the composite function, then we can find the composite function with the object 4. The value of x is 4 now. So fg 4 equals to 10. 4 minus 20, you get 40 minus 20, which is 20. That will be the answer. Now we come to this gf negative 1. So again, from here, we need to know that this is actually this. So we replace the fx with the 5x, you get 5x. And the 5x is now substituted into here, into here. So now it becomes 2 5x minus 4, you get 10x minus 2 times 4 is 8. So now we can find the value of gf negative 1, which is gf negative 1 here is 10 negative 1 minus 8. You get negative 10, so it's a negative 18. Now we come to the 2 example questions, which is one of the more popular types of questions, where you have a composite function like this fg. You are given one of the function f, and you need to find another function, which is g here. Here we have 2 example questions. The second one is also you are given a function gf, composite function gf. You are given one of it, which is f, and you need to find another function g. So what are the difference between these two? Later we'll look at the difference. We try to solve this first. So you look at this. The g, we say g is inside the composite of function of f. So now, based on this given composite function here, write it down is fgx equals to 6x minus 1. So from here you can see that actually gx is inside the f function. If we compare this equation to this function to this function, we can see that the x here is the gx here, meaning that we can replace the x here with a gx. We substitute gx into the x here. So when we substitute gx into this x, we are also substituting gx into the x of the function f. So from here you see, from this function, if x here is gx, then this x will also become gx. So it's 3gx plus 5. So now we have 2 composite function with 2 same composite function, whereas this part is different. So by comparison, this is equals to this. So it's 6x minus 1 equals to 3gx plus 5. So if we can just move the gx to the left hand side, we move the other values all to the right hand side, we can find the function of gx. So I just do it now. This one is a negative 5 equals to 3gx. So this one is 6x minus 6. And then we bring the 3 to this side, it becomes divided by 3. We simplify it, we get the 3 here can be divided with the 6 and the 6 here 2. So you get 2x minus 2 gx. So gx equals to 2x minus 2. Now we look at the other one. What's the difference here is that the location of the function that we are looking for is outside. Okay, this one is inside f. This one is outside of f. When you have this condition, this situation, the methods is different. So the method is actually looking for the inverse of the fx. But until now we haven't learned about the inverse. You'll learn about this in the coming the next video. So we just try to go through the steps. Okay, so first we need to know that we need to note that fx equals to 3x plus 5. So fx equals to 3x plus 5. We let y equals to function of fx. So means y equals to 3x plus 5. Then you try to find the subject of x. We find the subject of x means we want to make it, we want to try to move around the values and unknowns so that we get x as a subject, which is equals to something. So we try to move the values there. Y minus 5 equals to 3x. So y minus 5 over 3 equals to x. So x equals to y minus 5 over 3. After we find the x, now we can come back to this composite function. We write this down, composite function g f x equals to 6x minus 1. We try to convert all of this from the x to y. What I mean here is, you see, since y is equals to 3x plus 5, which is this, mean that y is equals to the fx. So the fx here now becomes the y. So it's y. And the x here, since we already get the subject x here, we also try to make x becomes this. So x becomes y minus 5 over 3 minus 1. And then we simplify it. So you get gy equals to this 3, and 6 becomes 2. So you get 2y minus 10 minus 1. So you get 2y minus 11. And then we rewrite this using the x to find that the function of gx equals to 2x minus 11. Question number 5. Question number 5. Given the function fx equals to x plus 1 over x minus 1, where x is not equals to 1, because if x is 1, 1 minus 1 will be 0. When you divide with 0, you have an undefined answer. Okay, so find the expression for f2, f6, or f and f11. So to do this, this is of course a composite function because it involves combining two functions. Okay, so we rewrite this f2 in fx form. Okay, so meaning that we substitute the fx into the x here. If we substitute the fx into this, meaning that this x and this x will also be fx. So we get something like this, which is fx plus 1 over fx minus 1. So fx itself is also x plus 1 over x minus 1. This fx is x plus 1 over x minus 1. So you have f2x. Okay, so to solve this, because since 1 is not a fraction, we try to make it a fraction which has the same denominator as x minus 1 in order to let us add the numerator. So you have x plus 1 over x minus 1. The 1 here now becomes x minus 1, x minus 1. That applies to the denominator part, which is x plus 1, x minus 1, minus x minus 1, x minus 1. And now here, since the denominator is the same, we can add the numerator. You have x plus 1 plus x minus 1 over x minus 1 over the lower part, x plus 1 minus x minus 1 over x minus 1. So when there's a fraction divide another fraction, when we change the division into multiplication, it actually becomes we switch the position of these two. So then this actually can be divided, cancel off with this x minus 1. So we just cancel it. You get x plus 1 plus x minus 1 from here. And then from here you have x plus 1 minus x minus negative becomes positive plus 1. Plus 1 and the minus 1 cancel each other off, so you get x plus x, which is 2x. X and x cancel, plus 1 you have 2. 2 and 2 cancel, you get x. So f2x is actually equals to x. Now we proceed with the next one. Now we have to find f6. f6x is actually equals to f2, f2, f2x. 2 plus 2 plus 2 is equals to 6. Again, remember this is not squared, and this is not a power of 6. It just means that there are 6 f composite function, which consists of 6 f function. So f2x here actually is x. So meaning that this actually becomes an x. So you have f2 x. Again, f2x is equals to x, and f2x equals to x. Now we look at the next one, f11. So f11, so I think you know that every f2x becomes an x. So f11 actually is f2. The last f, I think I put it in front here to make it easy. So we have 1f plus 10f here. So you have 11f. So we know that fx equals to x, f2x equals to x, f2x equals to x, f2x equals to x. So we do it 5 times. In the end, we have fx. Okay, I'll try to make it so that you can see it. Also, you have f2. This becomes x. Now this f2x becomes x again. So we have f2. This becomes x. So you have f2. This becomes x. You have f2x. This becomes an x. You have f. So in the end, fx that's why I wrote here in the first place. Okay, so you can skip all of this if you understand. And fx actually equals to this. So you have the answer x plus 1, x minus 1. So f11x equals to this answer. Now we continue with the next question. Given fx equals to px plus q and f2x equals to 25x plus 8, find the value of p and q, given that q is greater than 0, meaning that p is greater than, meaning that p is a positive value. So since we are given this with a value, so we try to take the function of f, we try to obtain f2x. We try to do this first. So we have fx equals to px plus q. So f2x, which is equals to fx, okay, meaning that we substitute the fx into this, so this becomes fx. So you have p fx plus q. Fx again equals to px plus q. We multiply, you get p square x. Multiply, you get pq plus q. So f2x equals to this. We compare to f2x equals to 25x plus 8. If we compare to this, we'll find that this x and this x is the same, so p squared equals to 25. P squared equals to 25, and pq plus q equals to 8. pq plus q equals to 8 if we do comparison. So p squared equals to 25, p equals to square root positive negative of 25, which is positive negative 5. Remember, it says p is greater than 0, meaning that p must be a positive value, so p equals to 5. Whereas this part, since we already know p is 5, so we substitute p with 5, get this, 5q plus q is 6q, so q equals to 8 over 6. You simplify this, q equals to 4 over 3, and that will be your answer. We look at the last question here. So you're given fx equals to x squared plus 1, and another function g is such that fg, the composite function, equals to x squared plus 4x plus 5. Find the function of g. So first you look at this. The g is inside. It's inside. So it's if you go back and see the examples questions that I gave just now, this will use the first method, the first method to solve this. So in order to solve this, we just substitute gx into here. Okay, so when this is gx, this becomes gx. So we write, you see, fx equals to x squared plus 1. When this is gx, okay, so this one is the same as this, the x here becomes gx. Gx is let me see, so now we have a gx squared plus 1, gx squared plus 1. So we do comparison. We compare this to this. We compare this to this. You'll find that this is equals to this. So gx squared plus 1 equals to x squared plus 4x plus 5. So you try to move the values there. So you have gx squared equals to x squared plus 4x plus 5 minus 1. You have x squared plus 4x plus 4 with a square here. With a square here. So since the square here, we want to move here to become a square root. So we know that there must be something here that we can make this into something squared, so that we can cancel off with the square root when this square is bring to this side. Okay, if you don't understand, never mind, we just continue. You see, yeah? I bring this square over to this side, it becomes a square root. And then we try to factorize this. Okay, so we factorize this, you get that. You can use your calculator. You just factorize this, you get x, this is 2, this is 2. So actually it's a positive 2, positive 2. Okay, so x plus 2 times x plus 2 is actually equals to x plus 2 squared. So the square and the square root, you can cancel off. You get gx equals to x plus 2. So that is how you find the function of gx. Thank you.